Hello everyone, and in this video we're going to be looking at infinite limits. We're continuing our study of calculus and limits. So let's look at these examples. So when you go to infinity, x is getting bigger and bigger and bigger and bigger and bigger continuously. If you go to negative infinity, x is getting smaller, 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 smaller. So let's look at this first example. Limit as x goes to infinity of this polynomial. So whenever you have a polynomial divided by another polynomial, you want to look at the powers of x. So if you have, we have x cubed on top, that's the highest power, and then we have x squared on the bottom. So those powers of x are going to influence this graph the most. Okay, the other powers will influence it, but not when x goes to infinity, really. Those other x squared on top and the x and the constant terms, that's not going to affect it that much. So a pretty easy way to solve this is we can say this equals the limit as x goes to infinity of x cubed over x squared, okay? Because those are the terms that's going to impact it the most. And the 5 doesn't matter on the x squared either. So we can say this equals the limit as x goes to infinity of x cubed over x squared is x. And then we don't want to say it equals infinity, we want to say it approaches infinity. Or you can write does not exist, because infinity does not exist. Next problem. We have x to the 5th. We have an x to the 5th, that's the biggest term, over an x to the 9th. None of the other terms matter, because it's a polynomial divided by a polynomial. I'm going to say this equals the limit as x goes to infinity of x to the 5th over x to the 9th. That's the limit of 1 over x to the 4th. Now remember your basic limit introduction. 1 divided by a really, really big number approaches 0. Now let's look at this one. So these first two cases were, the first one was if the power of x on top is bigger than the bottom. And then the second one was if the power of x was smaller on the bottom than on the top. So if it's bigger on the top, it goes to infinity. If it's smaller on the top, it goes to 0. What if they're equal? That's this third example. So again, we only consider these biggest powers of x. So that equals the limit as x goes to infinity of 2x squared over 4x squared. This time we have to consider the coefficients because you'll see why in a minute. The powers of x here will cancel. They'll go away because they're the same thing. They're going to influence the top and bottom equally. So that's going to equal the limit as x goes to infinity of 2 over 4. The limit of a constant is just the constant, so this equals 1/2. 2 divided by 4, 1/2. Now, what if it's a little more unintuitive? What if it's a square root? So this means that we can ignore all the other, we can still ignore all the other constants, all the other lesser powers, but we still have to consider the square root because the square root will affect x's power. So what I mean by that is that's equal to the limit as x goes to infinity of the square root of x squared. Okay, we still have to consider the square root because that'll affect x's value, okay? And that's over x. Now we can take its square root. So x over x. This equals the limit as x goes to infinity of 1. This equals 1. Okay? So pretty basic so far, not too many tricks so far. Now we'll look at special cases of these limits. Let's look at trig functions. If we want to do the limit as x goes to infinity of sine of x, or the limit as x goes to infinity of cosine of x, remember these functions they oscillate, okay? So if I draw the graph of sine here, it'll go up, it'll peak at 1, it'll go down to -1, and then it'll go up again. So this graph oscillates. It never goes beyond -1 or 1, okay? But since it just keeps going back and forth and back and forth, we can't say really anything about if x goes to infinity, because we could look at any of those points. So what we say is these limits do not exist, D and E. They don't exist. That's what we say about those limits. Now, if we look at the next problem, what if we divide them by x? Well, we said the top limits don't exist, sine and cosine, but the bottom limit does, the limit as x goes to infinity of x. If x goes to infinity, you're going to have sine of x over infinity, and something over infinity is 0. So both of these are equal to 0. Okay, even though the trig limit doesn't exist, the bottom limit does, and it goes to infinity. And since -1, anything between -1 and 1 divided by infinity is 0, those limits are 0. Now, what if we have limits involving negative infinity? Pretty much the same thing, just you need to consider the negative side, I guess. So this will equal the limit as x goes to negative infinity, and we still got to consider those highest powers. Since the power on the top and bottom is equal, we have to consider the coefficient. Really, you should consider the coefficient every time to make it easier on yourself, but those will go away. That equals the limit as x goes to negative infinity of -1. This equals -1. And then something I don't have on this page, but I want to show you, is what if you had the limit as x goes to infinity of the square root of x over x squared? Well, that equals, you got to remember all these laws and from algebra and pre-calculus. The square root of x equals x to the 1/2. So you have to break it down into its exponent. So this equals the limit as x goes to infinity, x to the 1/2 over x squared. This equals the limit as x goes to infinity of, it would be 1 over x to the 3/2, 1 over infinity, 0. Okay, and that should wrap up this video. If you have any questions, please leave them in the comments. Thank you.